Microsoft Phi 1.5 is revolutionizing AI code and tests LLMs scaling law to highlight the key principle for the textbook quality dataset. Learn more about Phi 1.5's redefinition of core AI standards and the implications for future AI development by watching the video. Training AI big language models have typically been the domain of well-funded organizations like OpenAI, Meta, and Google, due to the significant processing power required. This conventional wisdom is being questioned by the Machine Learning Foundation team at Microsoft Research, led by Sebastian Bubeck, with their work on open-source and resource-effective models like Phi 1.5. Microsoft Research has accomplished this once more. Researchers have now unveiled Phi 1.5, a cutting-edge language model with 1.3 billion parameters that exceeds Llama 2's 7 billion parameters model on a number of benchmarks after outperforming Meta's Llama with Phi 1 in July. Microsoft has chosen to make the model open source. What are large language models? A huge language model is a form of advanced language model that is developed on a vast amount of text data using deep learning techniques. These models are capable of producing writing that appears human and carrying out numerous tasks involving natural language processing. The definition of a language model, on the other hand, refers to the idea of ascribing probabilities to word sequences based on the examination of text corpora. There are different levels of complexity for language models, ranging from straightforward n-gram models to intricate neural network models. But the phrase large language model typically refers to models that make use of deep learning methods and have a lot of parameters, from millions to billions. These models are able to capture intricate linguistic patterns and generate writing that frequently blends in with human-written content. How are LLMs built? A large language model is a large-scale transformer model that is often too large to execute on a single machine. As a result, it is offered as a service using an API or web interface. Large volumes of text data from sources including books, papers, web pages, and many other types of textual content are used to train these models. The training process allows the models to examine the statistical connections between words, phrases, and sentences, which allows them to produce responses to questions or prompts that are logical and appropriate for the given context. The Phi 1.5 model, with its amazing 1.3 billion parameters, has been painstakingly designed to be the industry standard for a wide range of applications. It excels especially well when handling QA-formatted questions, as well as in chat conversations and jobs involving code. With the release of Phi 1 and Phi 1.5, the quest for robust AI programming has taken a new turn in the quickly developing field of artificial intelligence. These groundbreaking models are not only changing the way code is generated, but they are also upending accepted knowledge about how AI should be developed. These models have shown that the key to advanced AI capabilities may not lay in mere quantity, but rather in the quality and method of training by utilizing textbook-style datasets and synthetic data synthesis. Microsoft, the innovator behind these models, has shown how, with the proper approach, AI may develop programming skills that are comparable to those of humans, without the need for extensive parameters. Explore this page to learn how Phi 1 and Phi 1.5 are advancing foundation AI and what this means for the future of AI development. The advent of expansive language models like GPT-3 recently proved the power of scaling up parameters and training data for text production. With 175 billion parameters learned on hundreds of billions of tokens, GPT-3 demonstrated great performance on a variety of natural language tasks. Naturally, these bigger is better researchers applied philosophy to the creation of computer code. Early attempts, however, produced underwhelming outcomes. Only moderate increases were shown by other models like CodeGen and PalmCoder. Even if they use up to 540 billion parameters, they do not get the intended results. Unquestionably, large language models have demonstrated outstanding performance in the area of natural language processing. Their achievements will profoundly and widely impact the economic environment, but they have yet to completely reimagine the artificial intelligence framework or even cognition itself. On the other hand, the improvement of LLMs appears to be primarily motivated by their immense size. Modern state-of-the-art models frequently approach the mind-boggling realm of billions of parameters and tokens, necessitating significant resources for deployment, training, and maintenance. Costs unavoidably rise as a result of this exponential scale increase. Thus, The urgent question of how compact can an LLM be while maintaining its capabilities arises. A committed research team at Microsoft sets out on a mission to investigate this question in a groundbreaking document titled "Textbooks Are All You Need to" Phi-1.5 Technical Report. They present Phi-1.5, a model with 1.3 billion parameters that was trained on a sizable dataset of 30 billion tokens, astonishingly outperforming models 5 times its size. Furthermore, it excels at complex reasoning tasks better than the majority of non-frontier LLMs. This project expands upon the groundwork established by Microsoft's groundbreaking transformer-based model Phi-1, which was unveiled in June of this year. Using high-quality textbook training data, Phi-1 was able to outperform the formidable GPT 3.5 with just 1.3 billion parameters. The Phi-1.5 model features 24 layers and 32 heads, and each head has a dimension of 64, maintaining the exact Phi-1 architecture. Rotary embedding, flash attention for voice training, and the code gen mono tokenizer are some other improvements. The training data for Phi-1.5 combines the training data from Phi-1 with artificial textbook-like data that has been painstakingly designed to improve common sense reasoning and general knowledge acquisition. Unlike Phi-1.5, which was exclusively learned on synthetic data, Phi-1 was trained using high-quality textbook data. Phi-1.5 stands out for its thorough training program that includes a wide variety of data sources. The Python code snippets from Stack Overflow, code from competitive programming competitions, synthetic Python textbooks, and exercises produced by the potent GPT 3.5 Turbo 030 are only a few of the data sources used in the model's learning process. The Microsoft research team, the brains behind Phi-1.5, claims that for models with fewer than 10 billion parameters, this model has nearly attained state-of-the-art performance standards. Phi-1.5 has emerged as a strong competitor in rigorous benchmark examinations that assess common sense, language comprehension, and logical reasoning. Notably, Phi-1.5 rose over Meta's Llama 2 7b in the AG Evil score and is getting close to parity with Llama 2 7b in the GPT-4 All benchmark suite, as determined by the LM Evil harness. On the Microsoft official website, the technical report says, "We follow the textbooks are all you need approach, focusing this time on common sense reasoning in natural language, and create a new 1.3 billion parameter model named Phi-1.5, with performance on natural language tasks comparable to models 5x larger, and surpassing most non-frontier LLMs on more complex reasoning tasks, such as grade school mathematics and basic coding." That's it. What do you think of this efficient and cutting-edge technology? Leave your thoughts in the comments. For more videos like this, subscribe to our channel. See you in the next video.